3 says a company designs spinning toys using the family of functions y equals cx square root 4 minus x squared, where c is a positive constant. The figure above shows the region of the first quadrant bounded by the x-axis. Shh. And the graph of y equals yada 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 for some c. Each spinning toy is in the shape of a solid generated when such a region is revolved around the x-axis. Both x and y are measured in inches. Find the area of the region in the first quadrant bounded by the x-axis in the graph of y equals cx for c equals 6. Yes. Okay. So if we're going to do this, there's a definite integral problem, right? Since the area under the curve is just the area under the curve, what do we need to do before we can start doing the integration, though? You have to find the limits of integration, right? So if you have like this thing, we need to find the zeros, right? So you'd want to start by doing, oops, this. So zero product property, x equals 0, square both sides, subtract the 4 over, divide by -1, and then square root both sides, you get plus or minus 2. How do I know which one I want, -2 or +2? Positive 2. Clearly from the picture, number 1. Number 2, we're told x is a measurement for the top or the spinning toy. I'm going to call it a top because what else is that going to be? And obviously a measurement has to be positive. So this is what we're going to be integrating. Everybody cool with that? How do I do this? This is the non-calculator section.
It's a U.
This is a U substitution problem.
Inside 1 minus x.
And the reason you should see the U sub is you have like one function inside of another, right? Anthony?
Split that up too.
You can't, because you can't distribute the 1/2 exponent on the radical across this subtraction. So like the square root of a minus b is not the square root of a minus the square root of b.
No, not the inside. I meant the 6x and the square root of y. You split the 6x and the square root.
No, because the multiplication symbol between them, integration, you can split an addition and fraction.
Oh, that's right.
But we can't split across multiplication.
Okay.
So this is a straight U sub problem. What should our U be? 4 minus x squared. So du then is -2x dx. Okay, so when we solve that for dx, we get that, right? Actually, let's leave the x over there because we have an x in our problem. So this part is going to be u, and then this part is going to be du, or du over -2. You guys buy that? So 0 to 2, 6, and then we have square root u, and then we have our du over -2. So we'll 6 times -2 is, or 6 times 1 over -2 is -3, so we'll pull that out front. And then I would think about the square root of u as u to the 1/2. So it's the integral of u to the 1/2. This is like the most simplest integral we can do, right? Anybody?
It's 2u over 3 to the power.
Everybody go by with that? That's what we're doing? Yes, it simplifies down to what you said, Josh. But I'll write it in the simplest way possible for us.
So, oh.
So that simplifies down to, oops, we have 2. Everybody's okay there? Now, I didn't mess with my limits of integration, so either I would have to convert those so that it's in terms of u, or what I prefer to do is I'm going to dump the x back in there. Is that okay? So when I plug the 2 in, that's nice. Because what's that just turn into there? Just a 0, right? Because I have the 4 minus 2 squared. So that just zeroes out. And then when I subtract by 0, zero minus 2 is, oh, I'm sorry. I put it in the wrong spot. This was not 4 minus x squared. It was, oh yeah, 4 minus x squared. Oh, yeah, so it's 4 minus 0 squared. Cheapers, creepers. There we go. So that's 4 minus 0 squared is 4. The square root of 4 is 2, and 2 cubed is 8, and then times negative 2 is negative 16. And then make sure your unit's on there. It told us that the measurements were, the x's and y's were measurements in inches in the problem.
So, I know that earlier in the problem, we solved for x is plus minus 2, we used that in the integration.
Mm-hmm.
How do you know that that's what you're supposed to do?
Because it says that in the problem it says find the area of the region in the first quadrant bounded by the x-axis. So it's like this area that I colored there in red for the curve. So it's literally just going from x-intercept to x-intercept.
Okay.
Does that make sense?
Yeah. So does that mean x would also intersect at -2 if there's a whole graph?
No, because of the way the function was defined in the words.
Okay.
But yeah, since we are limited to the first quadrant, you know immediately x can't be negative in the directions it says in the first quadrant. So that's part A, which is a, not an impossible integration, but that's challenging. It says it is known that for y equals cx root 4 minus x squared, the derivative of that is yada, yada, yada. For a particular spinning toy, the radius of the largest cross-sectional circular slice is 1.2 inches. What is the value of C for this spinning toy? So what they're saying here is we have some toy where this is the 1.2, right? How is that going to be helpful to me? Well, what's the derivative going to be at that point? Anybody? The derivative has to be 0 there, right? So I'm going to use that to solve for c to find the value for x. Once I've found that value for x, or once I found that c, or I'm sorry, once I found that value for x, I can find the c. So I'm curious about what this x is. So I'm going to start by doing solving 0 equals, this is the derivative that I'm plugging in. It gives you the derivative in the problem, so we don't need to solve that, or to find the derivative. It's given to us. How do I solve this equation?
Multiply by.
Well, it's a fraction, right? So when is a fraction equal to 0? When the numerator is 0. So I can just ignore the denominator for now. And then I can apply my 0 product property. Now clearly c can't equal 0 because you would not have a function in that point, right? Because it's the y equals cx times yada yada yada. So can't have that. So this is the piece that I care about. So I can subtract the 4 over, divide by the -2, square root both sides to get plus or minus 2. And again, I know that x is a length, so it can't be negative. So that's what I need. What am I going to do with that now? I know that 1.2 is going to equal square root of 2x times, or I'm sorry, c times square root 2 times 4 minus square root 2 squared. Right? So this is f of square root 2 equals 1.2. And then I just need to solve for c. There's no calculus going on in this particular part, right? Everything I've done is just algebra and understanding the relationship between a function and its derivative. Like that's the only calculus I've used so far in part B, is just like understanding that, hey, where this thing's at its maximum, the derivative has to be 0. And then it's all algebra after that. I know. So that's going to give me root 2 times root 2, which is the same thing as 2. So 1.2 divided by 2 is 0.6. That's doable. It really is. Well, again, like if it's a story problem like this, don't start until you understand what's going on. Like read it and think about it. Don't be in a hurry to start doing math.
I forgot about that 0 property.
Well, this is, yeah, it's like critically important solving tool. Critically important. All right, and then part C. For another spinning toy, the volume is 2 pi cubic inches. What is the value of C for this spinning toy? How is the volume related to this? We're talking about a solid of revolution, right? So yes, we're integrating. What kind of shape are we going to be creating when I rotate this thing along the x-axis? It's going to look like a top, right? It's going to have a point at the bottom and kind of get bulbous at the top, right? Like a top. How am I going to calculate the volume of that? I'm going to use the washer method. Yeah. Right? So we're going to take washer slices of this along the x-axis. Right? Like I'm going to take washers like this. because it's kind of making that kind of a shape or whatever. Does that make sense? Okay. So the washers are really cylinders. They're little tiny cylinders. Everybody agree? Or discs, I guess I should say. They're not washers. There's no hole in the middle here. Just discs.
Wait, so is this?
Discs. My apologies. Yeah. Not washer. There's no hole in the middle. Just a disc. Thank you.
Washers are there's a hole in the middle?
Yeah.
Isn't there another?
You can do the wrappings where like you're taking the shells. That's what it is. Yeah. I always forget the names of these things. It's been too long. But yes, that's another approach. You could do this one with shells also. I think it's really unnatural to do it that way.
Okay.
I think that this is most obviously a disc one, but you could do it with shells also. All right, volume of a cylinder. How do you calculate that?
2 pi radius.
2 pi r squared h. So 2 pi, the radius in this is going to be the function. It's the height of the disk, right? Or the radius of the disk is the height of the function. So we have our function squared. And then what's the height? That's the dx. Because it's an infinitely small little slice, right? It's basically a disk with no height. My page here. Oh, I don't know why I wrote 2 there, just pi. So we have 2 pi should be equal to this, right? And we're solving this for c.
Oh, yeah. They plug this back in.
They paused time, did something.
Everybody agree that that's what we're doing?
Oh, actually,
Okay. Well, let's start. So the first thing I would do is distribute the exponents. Come on. There we go. Everybody's good with that? The squared cancels the square root, which is awesome, because what does that remove? Any need to do a u substitution here, right? Which, fan-frickin-tastic. Let's pull that c out front, because I know that's a constant. And then I'm just going to distribute the x squared through. And now, Anthony, this is a place where we can split the integration, right? Since the two terms are being subtracted. So we have to be a little bit careful there because we have... We could do that.
Okay, yeah.
Right? And that's nice because both of those are super easy integrals. So that's going to be x cubed over 3. I'll just put the 4 there. Minus x to the 5th over 5. And evaluating from 0 to 2. Oh, come on, stupid pen. There we go. So far, so good. Yeah, so that's all 0. That's nice. And so do I have here? I have 2 to the 3rd is 8 times 4 is 32. 2 to the 5th is 32. So to subtract those, what do I need to find? common denominator, so multiply the first one by 5 and multiply the second one by 3. So to solve for c, I'll multiply by the reciprocal. So I have 2 pi times 15 over 64 pi is equal to c squared. So the pi's cancel, reduce that down. So I have plus or minus the square root of 15 over 32. And we know that c has to be a positive value because that's the way it's defined. And that'll be good enough. So not terrible integral. You guys want to try another?
Yeah. I'm gonna try this one. I more or less just watch. Let's see if I can do this next.
Yeah. Should we do 4 then?
Yeah.
All right. I'm going to actually, well, I guess I can't. I don't have it. Do I have it right here? I think I do, actually. Because this one is using a graph. There we go. All right. Fiddlesticks. All right. So here's 4. It says let f be a continuous function defined on the closed interval from -4 to 6. The graph of f consisting of 4 line segments is shown above. Let g be the function defined by g of x equals the integral from 0 to x of f of t dt. On what open interval is the graph of g concave up? Give a reason for your answer. What does that remind you of? That was not what I thought when I saw that. That to me is the fundamental theorem of calculus, right? That is just the definition of a derivative. So what that tells me then is that g prime of x just has to be f of x. So all I'm doing is I'm using my graph to do my derivative test to determine where the graph is concave up or down, right? So the what do I care about then? Yeah, the zeros. Or actually, let's think about it this way. So like if I'm graphing the second derivative then, so this is like the same thing as g prime, right? If I want to graph g double prime, the slope from -4 to -2 is, looks like we went 2 over and 6 up, so is 3. And then the slope from -2 to 4 is going 2 over and 2 down. So that's like -1. So like you've gone and done, so like here, and then we're going down, 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 positive slope, negative slope, negative slope. So we're going all the way down to like positive 2, and then we're going back up to 6. Actually, this could be the graph of G, is really what we're talking about, right? So we have like positive slope, negative slope, and then positive slope again. So the place where we're concave up, no, I've screwed that up. What did I do here? So let's, I think I do want the second derivative, right? What's the,
Or it's something outside. It's like they're open doors.
what's the second derivative rule for concavity?
I'm pretty sure it's the zeros at the second derivative.
Well, that's where the inflection points are. That's where the change in concavity occurs. But if the derivative is positive and the second derivative is negative, that tells you something, whether it's concave up or down, and vice versa, right?
I don't know after that. It's been so long.
This would be one of those things that like would be desperately good to memorize. What is this? This is the second derivative test.
Second derivative.
Let's see what we get. Okay, so if the derivative is positive, and then where is it? Oh my goodness, this is like the super technical. Okay, if the second derivative is positive on some open interval, then f is concave up on that interval. Okay? And then if it's the second derivative is negative, then it's concave down on that interval. Right? So the slope here is positive, and the slope here is positive. So it's just going to be from -4 to -2, or from 2 to 6. That's it. Okay. The next piece says, let P be the function P of x equals G of x times f of x. Find P of 3. Oh, sorry, P prime of -3. So P prime is going to be the derivative of G of x.
So where is it concave up? It's only -4 to -2 and 2 to 6.
Yep. Just the places where the derivative has a positive slope.
So it wouldn't be from 0 to 6.
Correct.
Oh, because that's a prime graph, yeah.
Okay. So if I want P prime of x, that's just the derivative of P. So I had to do the product rule there. Right? So note here that the derivative of G of x is just f of x based on the definition that we looked at before. Right? So P prime of 3 is going to be f of 3 times f of 3 plus g of 3 times f prime of 3. How am I going to get f of 3? I just,
Very lost.
oh, well it says, it gives me P,
Yeah.
so there's my P. It asks me about P prime, so I calculated P prime using the product rule, because I have the product of two functions, so to take the derivative of that, I use the product rule. So I have f of x times the derivative of the first, and then the second times the derivative of the first.
Okay. The derivative of both those is just.
And based on what our observation from earlier, we know the derivative of g is f of x. So I made that substitution.
Okay.
And then the derivative of f is, I'm just going to write as f prime. And we're going to calculate all these things in a moment.
Okay.
So f of 3, I can just read from the picture, right? 3 is here. So f of 3 is negative 3. F prime of 3, what's f prime of 3 mean? What is the derivative the same as? I'm going to do this part now. What's the derivative the same thing as? In a graphical sense. Slope! So all I need is the slope on that line segment. So what did we do? We went 4 up and 4 over. So the slope there is just 1. So the only difficult piece is going to be getting g of 3. Everything else I just read directly from the graph. How do I calculate g of 3? Well, and what's the same thing as an integral? Geometrically speaking. Area under the curve, right? So we're looking at those areas, right? So g of 3 is going to be 1/2 4 times 1 for the first triangle because we're 4 high and 1 over. The second triangle we have base 5 and height 4. So we're going to have minus 1/2 4 times 5. So that gives me negative 16. Oh, sorry. That's 2 minus 10. That's not right. Negative 8. I had negative 3.5. How did I do that? What did I do wrong here? So that's 5. That's right. And the height there is 4. Oh, cheapers creepers, guys. It's because we're only looking at that area. That's why, right? So I'm going to break that into a triangle and a trapezoid. That's better. So the triangle just has height 4, base 1, and the trapezoid has heights 1 and 3, or bases 1 and 3 and height 1. So there's my negative 7.2.
How do you do the area of the trapezoid again?
It's 1/2 B1 plus B2 times height. You're welcome.
Oh, and that's whoever decides the height.
Yeah, yep. So,
4 and 3 in this case, right?
1 and 3.
Why is it 1 and 3?
So, yeah.
So height is 1 and this is 0.3.
Yes, sorry. I just couldn't read my own penmanship, I guess.
Guys, we're taking the last calc class.
I'm so sad.
Yeah, we are. Fine, I mean, no one's gonna be ready. Yeah.
And then part
Brian.
C says find the average rate of change G on the interval -4 to 2. Does the mean value theorem guarantee a C
They're not in it. Yes, we go.
between -4 and 2 for which G prime of C is equal to the average rate of change?
Wait, I'm sorry. Is the answer 7/2?
So the answer, Josh, for G of 3 was -7/2. But then when we plug it back in up here, we get 5.5 total for that P prime of 3.
Wait.
Right? Remember what we're
The
trying.
negatives cancel out, yeah.
Yeah.
So then it's 7/2, or -7/2 plus 9.
That's actually really cute.
Okay. So the answer is 11/2? Yeah.
No.
Yes, 11/2. Part C. This is a good one, guys.
Yeah.
Asks you to do this limit.
And then some what?
What's the problem here going to be?
It's actually really funny.
We know the limit of the denominator goes to 0, and the limit of the numerator we'll have to do by triangles, but also gives us 0. What do we do when we get 0/0 in a limit?
I'm at that again.
L'Hopital!
Yeah.
What is L'Hopital's rule? It's going to be equal to the derivative of the top and the derivative of the bottom. See you later. Which is great, because this is the same thing. You're welcome. If you guys have questions on this stuff, you can come see me. Happy to help. We're out of time.
I might come in and do a study session next week at some point.